stop change, and then we stop and return the rank of all the subscenes. On this graph, we can see how the rank value changes in time, well, in iterations. We see that in the beginning there is a lot of changes, while after a certain amount of iteration, the page rank values converge to some constant value. Another feature that has been extracted from a script is the character names. On this figure, we see the character presence of the characters of episode of the TV series Friends. Maybe like this it will be more visible. We can see that some of the characters appear a lot more often than the rest. So we want to find this limit where some character appear most, and hence their main characters. And to do that, we create this table, which is actually all the character names in the first column. Then we have the times of their appearance in the second one. And as we can see, the first 4 characters have their appearance in the interval between 40 and 55, while the next one has a visible difference in appearance. So we want to find this border, and to do that, we calculate the ratio between every two consecutive characters, which is shown in the third column. So we assume that main character of a particular movie are all the characters that appears after the first ratio bigger than 0.5. Why 0.5? Well, we investigated a lot of video content, a lot of movies, TV series, and this value appeared to perform good. Another assumption that we introduced here is that there is always more than one main character. Why do we do this? Sometimes there is only one character that appears really a lot, but we don't want to focus too much and maybe miss some important scenes. That's why we want to have more than one main character. And now when I show how do we calculate the values for these features, we can come to actually ranking our scenes. So the features that I presented so far are keyword rank, character rank, main character present, and I add here first or last appearance of a main character. We consider that the introduction of the protagonist of the movie and the time when he or she appears last is important for the storyline, so that's we add this simple feature as well in our rank calculation. And then we define an importance function which is calculated for every subscene, and which is the linear combination of the above listed features. The coefficients here, alpha, beta, gamma, and eta, we use them in order to tune the impact of a certain feature in the final result. Then we select the best segments of the summary according to this important function. We introduced 2 constraints. The first constraint is that we choose we choose the best subscenes out of every scene, and the number of scenes chosen from a particular scene is actually proportional to its duration within the whole movie duration. The second constraint is that the importance function, or this value, should be bigger than a certain threshold. Here is a plot of the importance values for all the subscenes in a movie. And we can see that some of them goes below the threshold and only few goes above this threshold. And we see that if this is one scene, there is some particular subscenes that have quite a big importance value. So we select the scenes that comply with the constraints I showed before to be included in our summary. We created a prototype in Java in order to see whether our method works. It takes MPEG-2 video as an input, and we tried to make the solution as scalable as possible, so that even if we change, even if you find a better solution for any of the summarization steps, we can include it without interfering with the work of the rest of the components. Then, how did we evaluate our work? We conducted a user test. The goal was to estimate user understanding and user satisfaction. We chose two algorithms, only two different combinations for this important function. We did that via some initial evaluation, which make use of precision recall and F-measure. And here we chose algorithm which is based only on subtitles. We can see that we use only the keyword rank here. The other algorithm is subtitle script based. It makes use of all the features that have been presented so far. Besides those two algorithms, we included in our user test also a random algorithm which doesn't use any features. It just assigns a random rank between 0 and 1 for every subscene, and the original version of the movie. Why do we do that? We want to somehow define a lower and upper bound for our evaluation. And so the random summary is supposed to produce quite bad summaries, while the original version contained the whole storyline. So the random will be our down limit, while the original version will be our upper limit. And our two algorithms are situated in between those two limits. As for the user satisfaction, we only compare random, subtitle-based, and script-based.